All right, so for today, again, looking specifically at mathematical models, but polynomials specifically. So I have this chart, and I only have up through the first 3 degrees of polynomials. Those are the most common ones used when you're modeling. But I have on here the general formula for any polynomial that looks super messy with all of the variables in it. But in this model, n would be a non-negative integer. So n, notice, is not only with the subscripts for all of the a's, but that just a is representing a constant or the coefficients for the specific terms. N is really focusing on the powers on x. And if you have a negative power, it's not a polynomial. So n is a non-negative integer. The a's are the constants, the coefficients of the polynomial. So that's just what the general formula for a polynomial, what it looks like. The domain, all polynomials have the same domain. Domain for every polynomial is all real numbers or negative to positive infinity. We are writing that in interval notation. And then another characteristic, things we talk about regarding polynomials, is the degree of a polynomial. And the degree of a polynomial, I actually didn't need the colons there, the degree is n, basing it off of this general form here, meaning the degree, you may remember with polynomials, it's the highest power on the variable, highest power on x. So just as an example here, if we had this polynomial, f of x is 2x to the 6th plus x to the 4th, that polynomial would have a degree of 6, highest power on x, a 6th degree. And then not every polynomial has the same shape for its graph, but polynomials of the same degree have similar shapes. So we're just going to look at the first 3 degrees. The first one we actually looked at yesterday, but now we're talking about it as part of the family for polynomial functions. So linear functions are polynomials of degree 1. I have the formula there. I'm only using the p of x because of the polynomial notation, but f of x, same idea. So I'm just going to put here polynomial of degree 1, or a first degree polynomial, we could say as well. And we already wrote in other specific characteristics for linear functions yesterday. We do know that the graph is a line. Again, I'll just draw one case, but that line could be increasing, decreasing, or horizontal. If it's vertical, it's not a function. We talked about that yesterday. So then, moving on to then the quadratic functions. So they have this general form, or this is one way, I guess, to express the general form. This would be the standard form, ax squared plus bx plus c. So this would be a polynomial of degree 2. And then we know the shape of a quadratic function is a parabola, which could open up or down. And so thinking about the formula or the equation for a quadratic function, how can you tell just by looking at the equation if the graph would open up or down? If the negative or positive, which the a, yes, specifically. So the coefficient of x squared. So if a is positive, it's going to open up. Negative, it'll open down. If a is equal to 0, it's not quadratic because there would be no x squared term. And then last one that we're just generalizing here because we could continue up for every degree, but they're just not as commonly used with models. So cubic function. So we have the general form here, ax cubed plus bx squared plus cx plus d. So polynomial of degree 3. And then all cubic functions, all third degree polynomials have the same general shape for their graph. So I'm going to represent it two different ways. One would be if it's represented as increasing. And then it could also be decreasing. And this is the same idea as with quadratics and their graphs, that if the a value for a cubic function is positive, the graph will be increasing from left to right, so it'll look like the top one. And then if the a value is negative, it'll be decreasing from left to right. So again, the whole goal behind going through all of these types of functions is making that connection between what the function is, what the equation looks like, and then what the graph looks like as well. So if you see an equation, you can just picture in your mind the general shape of the graph. Yes, you have your graphing calculator that can graph any function for you, but if I haven't said this already, AP test, half of it is with your calculator, half of it is without. So you can't use your calculator for everything. So just having that understanding and being able to visualize what a graph should look like, or seeing a graph, knowing what type of function it is and knowing a little bit about the equation, that can all be very helpful. So there's one example I have, and then we're going to see where we're at time-wise. But for this example, like I said, you need your graphing calculator. Does anybody need to borrow one? Okay. Would you mind, just so I don't have to walk through the maze of desks, so in the cabinet on the bottom, very bottom shelf is where the graphing calculator is, the blue bin, if you just want to pull that out and set it on the desk. Thanks, Dylan. I'll talk while they're getting calculators because we won't start just yet. So in this example, I'll just read through the scenario we're looking at here. A ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground, and its height, h, above the ground is recorded at 1 second intervals in the table below. Find a model to fit the data and use the model to predict the time at which the ball hits the ground. So we first need to find a model to fit the data, and we'll use the graphing calculator to find that model. So we're going to go through the same process we did yesterday, enter the data into the calculator, make a scatter plot to see what type of model would be appropriate, and then perform the appropriate regression using the calculator to get our function. And then we can use that model to answer the final question, when does the ball hit the ground? So as a review on how to enter that table into your calculator, you want to go to Stat, so third column, second key down, and you want the first option that's highlighted. We want to edit the lists. So you probably still have your lists in from yesterday, or if you did the assignment from number 16, we want to clear those. So the fastest way is to arrow up to highlight the name of the list, hit clear, and then enter, and it'll clear everything in the list. And do that for both. And once they're clear, you can start entering in our time in one column and then our heights in the other column. And as I said yesterday, just make sure that your last values do line up, that you don't have more values in one list than another. That means you missed one somewhere. Okay. Are we okay if I move on? And some of you, I can't tell, because some of you might remember what to do on your calculator, so if I am going too far ahead and you're behind and missing something, I can either repeat or just stop me. So once you have your list, this is more of something I just want you to make sure it's still set up the right way in your calculator, or as a review once it's all turned off, because it's probably still set up correctly based on what we did yesterday. So if you then just make sure that you want to make sure that your plot 1 is turned on and is set to make a scatter plot. So again, to check that is to go to second and then y equals for stat plot. So if you do see on this screen, if you see this is already set up, you can just stop here. You don't have to go into plot 1, but I can see for me, plot 1 is still turned on. I see the symbol that shows it's a scatter plot, and then I see L1, L2. Those are my two lists that my data's in. But if you needed to go into it and then fix anything, if you're perhaps using a school calculator and you're not using the exact same one that was used yesterday, you might need to change it. So just make sure plot 1 is turned on. Scatter plot, the first type option is selected, and then your X list and your Y list are the list names that you typed your data into. Are we okay here if I move ahead?
How do you change it?
Okay, if you need to change it, then if you look above the keys 1 through 6, if you hit second, you should see that you should be able to change it to L1. For example, like second 1 is L1. Yep. Okay, I'm going to move on if we're okay at this point. And then make sure to, I'm just going to hit y equals. Make sure along the top, only plot 1 should be highlighted. And then if you have anything typed in, I still have a regression equation in here from yesterday, so I'm just going to clear that to get rid of it. So you don't want any functions typed in at the moment when you're making your scatter plot. And if this is all good, then to get the best window for your scatter plot is to hit zoom and then option number 9. And again, you can arrow down to 9 and click enter, or just hit the number 9 and it'll give you the scatter plot. How did I get to this screen?
Yeah.
This is just if you hit y equals. Okay, I'm going to go back to the scatter plot. Anybody else? Again, if I moved too quickly, please let me know. I know you're all in different spots. But anybody have trouble getting the scatter plot? If yours looks drastically different, it could be that one or more of your numbers was typed in incorrectly. If yours not working. Okay. Yours isn't graphing? Are you getting an error message? Oh, okay. There's other ways to change the window, which I'm going to show you all the graphing the easiest way would be figure out where to go versus you having
No. I know, Ron. Don't put that in there.
It also wants one in 1962. So is Bergen going to be next game? Yeah, we don't game tomorrow.
Okay. Looking at the scatter plot, so this is to get an idea of what model would be appropriate to use. Would you say a linear model would be appropriate, or would something be better? Quadratic would probably fit better than a linear in this case. So I'm just going to make a note on here. We're going to use a quadratic model. Now, typically in the problems you'll work through, I'm not going to assign any problems where it's some major guess where it could be all of these different types of models and you're trying all of them out. Many of the problems will specify what model to use or will be clearly like a linear model or a quadratic model, or it will specifically tell you use this type of model so that you're not guessing which regression function to use here. So if we're using a quadratic model, we need to do the quadratic regression on the calculator. And the way we do that is the same as linear. We're just choosing quadratic instead of linear. So to get there, we had gone back to stat. And then we wanted to go to the calc menu along the top of your screen. So just arrow over once to the right. And where we did option 4 for linear regression, yesterday, right underneath it, you see quad regression. That's quadratic. I'll just explain this on the screen in case you need them. Cubic regression. The quart regression, that's the quartic. So if you had a 4th degree polynomial, that would be what that is. So quadratic regression is option 5. So you can either hit or go down to option 5 and click enter, or just enter in the number 5. And then just like yesterday, I believe you all said on your calculators you were getting a screen like this. Yes? Yes. Okay, awesome. So then X list, just make sure your X list is L1 or whichever you put your times into, Y list L2 or whichever you put your heights into. You don't have that on your screen. Okay, so then, oh yeah, because you have an E3+. So I will come over by you momentarily. I'll show you how to type it in. So then X list, Y list, again, you don't need anything for, I believe this is frequency. I'll be honest, I'm not sure because you don't need it anyway. And then store on regression equation. We'll do this. I'll show you again how to do this. I don't know if we'll exactly need it for this question, but if you did need it, I'll just remind you how to do it. So this is where we want this to say y1 so that when you go to y equals, it's stored in there. And again, to make it say y1, we went to vars, which is right to the left of your clear button. And then along the top, you want y vars, so arrow over to the right once. We are entering in a function, so enter for number 1, and then you can choose whichever y you wanted into. I usually just do y1. Unless I already had something in there, I might choose y2. And then it'll store it in there for us. Calculate and it'll give you the model ax squared plus bx plus c, and then it gives you a, b, and c. If you don't see r squared, it's okay, you don't need it. So if you don't have these values, again, some value in your table might be entered in wrong.
Oh, that's open. Dang, dude, it works. Hey, mom's open. That's Mark. Thank God. This is too big. This one's too big. Wait, hold on.
Anybody else having trouble? Yeah, sorry, this video is going to have long pauses where nothing is happening in it if you ever go back and watch this. Or I'll just apologize to anybody watching this, like Connor, who's not here right now. Okay, so if you, again, didn't get these specific numbers, you can continue with what we're doing so you know what to do, but it just means some value in your table was typed in wrong. So now we have the quadratic regression. Actually, I'm going to write down, just make a note of what these values are. So we have y equals ax squared plus bx plus c. Now I'm just going to write down each of these to 3 decimal places. So a is about negative 4.902. B is about 0.962, and C 449.364 approximately. So now with the storing part of it, that is a step you don't have to do. But now if I were to go and hit y equals, it is already put into my y1. So this is nice when you want it to graph, because also look, it puts in or enters in more decimal places than you perhaps would want to type in by hand. Just go to y equals. I just hit y equals. Yeah, so when you did the store regression equation, going in and putting y1 there, that is what happens when you do that. If I didn't do that step, that would not appear in y1. Just hit y1. Yeah, y equals. Oh, did you not do the store part of it?
Oh.
So if you didn't do the store part of it, you wouldn't see this. You don't need to, I mean, unless you want to go through and do it. I just was showing this step, but for this problem, if you didn't do it, it's fine. Right. Did you have a question, Megan? just hit the right arrow when you're, so I know what you mean. So like if I was typing in x and then raised to the 5th power and then hit the right arrow to get out of it. Yeah. Yeah.
So how many, you want 3 decimal places?
3 decimal places, yeah, if you're writing it down on your own. Now, I just wanted to show you this. If you had this stored, if you didn't for this problem, it's fine, because we're not actually going to need to use it. I was, again, just showing it. But now if you hit graph again, it'll graph your regression equation through your scatter plot. So if you had stored it, and then you hit graph again, it'll now graph your quadratic function with your scatter plot, so you can see how good of a fit it is. So, but again, that's just kind of for show. I wanted to show you that right now. We don't actually need it. So to get to how to answer this question, we have our model. The question is, predict the time at which the ball hits the ground. So if I were to put this into this equation, just write the equation out. So I have y equals the negative 4.902x squared plus 0.962x plus 449.364. So here's my quadratic equation, or I could have, had f of x, quadratic function. How do I predict the time at which the ball hits the ground? Yes, set it equal to 0. So the height, which I'm using y for right now, I would need to replace the y with 0 and solve. So I'd have 0 equals this whole thing. No. The question was, can the calculator just solve this for you? No, unfortunately. I mean, it could, actually I got ahead of myself. It could, you could solve it using the graph, but just algebraically, will it factor it or solve it that way for you? No. If you can, yes. So, and we'll get into this when we go through graphing calculator specific things. I can show you how you would use the graph to solve this equation. But if I was not using the graph to solve it, how would I solve this equation? Quadratic formula, yes. I would not attempt to factor this. Probably wouldn't factor. I'm 99% sure it wouldn't factor. So, quadratic formula, as, yes, if you ever need to use it, AP test does not give you quadratic formula. So if you were to need it for something, you would need to know it. Do you have it memorized?
Yeah.
Once you start saying it,
Plus or minus.
Do you sing the song?
No.
I've never heard this song.
You've never heard the song? Okay, I'm not a singer. I'll sing it. I'm not a singer, so don't judge me. So, well, here, I'll write it first, but I will sing it because if the song helps people. I still sing it to myself when I write it down.
Yeah.
I bet you I did.
All right, so hold on. I'm going to stop the recording. I don't want my voice recorded on here.